Now in this video, we'll see the DMVPN Phase 1 routing using EIGRP protocol. Now before we go ahead, let me just give some basic idea of what are the initial configurations done in this lab. Now in this lab, I got the DMVPN Phase 1 configurations which are pre-configured. Like on the router 1, I got GRE, a multi-point GRE configuration, and whereas on the router 2, router 3, router 4, we got point-to-point normal GRE configurations, point-to-point configurations. And then I'm using NHRP dynamic mappings. Now probably we can use either static mappings or dynamic mappings. Let's go and verify the same thing on the router 1. If I go to the interface, now I removed all the configurations what I did in the previous lab, like RIP configurations or whatever the commands enable, and I just have basic tunnel configurations which are required for you to have end-to-end reachability between the tunnel interfaces. I got NHRP dynamic, and then I got tunnel source and destination. There's no destination, it's a multi-point GRE on the router 1. But whereas if you go and check on the router 2, if I verify on the router 2, I got the tunnel interface and all the tunnel configurations based on the DMVPN Phase 1. Similar way, the same thing I got on the router 3 as well. So if I verify on the router 3, show an interface. So these are again the Phase 1 configurations, and the same thing I have on the router 4 as well. So you know the Phase 1 configuration, so I'm not getting into those things again. So all the routers are pre-configured with the DMVPN Phase 1, and let me test the reachability from the router 1 to the tunnel IP addresses of the other routers. I'm able to reach them. So the DMVPN Phase 1 is configured, but if I verify any routing protocols, I don't have any of the routing protocol except NHRP. Now what I want to do is I want to ensure that all my branches, router 1, 2, 3, 4 should be able to communicate with each other by using EIGRP protocol. So to configure EIGRP, we need to go with the normal configurations, like we go to router EIGRP, no auto summary, and then advertising the WAN interface, and then advertising the LAN interface. Let me do the same thing on the router 2, router 3, and router 4. Only the difference is I just need to change the IP addresses, right? I just need to change the LAN interface because the WAN interface still remains the same. So on the router 2, it has to be 2-dot network. On the router 3, it has to be 3-dot network. And on the router 4, we are going to configure it as 4-dot network. Now once we configure this, now I should expect the neighborship, but here the neighborship is not coming because if you remember, we discussed in the RIP also, by default, we need to ensure that whenever you're using any dynamic routing protocols, we need to tell the NHRP to allow the multicast traffic to forward it. Now if you want to tell that, then there are two specific configurations we can go with. Like either we can go with IP NHRP map multicast dynamic command, or we can go with the individual configurations on the hub router. So on the router 1, we need to add this command to allow the multicast traffic to pass through the DMVPNs. So to make that possible, we need to go to router 1. On the router 1, I need to say interface tunnel 1, 2, 3, 4. We need to say IP NHRP map multicast. Now we can specifically define the spoke addresses, like we can write 25.002, 35.003, and 45.004, or I can simply say dynamically learn destinations. Now once you configure this, I should expect the spokes has to form the neighborship with the hub. That's something what I should expect here. Show IP EIGRP neighbors. So let me try to shut down the tunnel interface and make them up. So just what I'll do is I'll try to shut down the tunnel interfaces, so which will again initiate the complete process. Let me do the same thing on all the remaining routers here. I'll go to router 1 and router 2, router 3 on the spokes. On the router 2, router 3, and then on the router 4. So now you can see the tunnel neighborship has been established here. So probably whenever you make any changes to the tunnel configurations, sometimes it doesn't come up. In that case, I suggest you to just make the tunnel down and then make it back up so it will reconverge again. So now we can see on the router 2, I'm able to see the neighborship, show IP EIGRP neighbors. Router 2 is forming the neighborship with router 1. And similar way, I should see the router 3 also forming the neighborship with router 1. And also router 4 is also forming the neighborship with router 1. If you verify the routes, if I give show IP route EIGRP, now again on the router 2, I can see 1.network is coming via tunnel interface. Let me verify the same thing on the router 3 as well. Show IP route EIGRP. You can see the router is coming here as well. Let's go to router 1 and verify the routes. Show IP route EIGRP. Now you can see the routes are coming, but on the router 2, I am not able to receive the routes from router 3 and router 4. Now the reason again because of the split horizon rule again, what we discussed in the RIP as well. Now here also we need to disable the split horizon rule. So we need to disable the split horizon rule on the hub router. So we just need to go to the hub router. On the router 1, we need to say interface tunnel 1234. We need to say no IP split horizon for EIGRP 100. Now once I disable the split horizon rule, you should see the routes will be coming on the router 2. If I give show IP route EIGRP, you can see the routes are coming. Now by default, split horizon rule will, what it says is an update coming, because normally the routes coming from the router 4, if it goes to router 3, it has to go to router 1 first, and the router 1 has to forward back again on the router 3. So which means the update received on the 1 interface should not be sent back on the same interface. So that's what exactly preventing the routes coming from the router 4 going to router 3 or router 2. So now what we can do is, in general, when we are using some hub and spoke kind of implementations, we need to ensure that we are disabling the split horizon rule. So that's what we did in the previous step here. Now to disable the split horizon rule, we need to add this command on the router 1. So no IP split horizon for EIGRP 100. Now once we disable the split horizon rule, now you should see the routes coming. If I give show IP route EIGRP, I can see the routes from the router 3 and router 4 are coming on the router 2 routing table. Now if you try to ping or trace to 4.4 network from the router 2, you can see it goes from router 1 because there is no direct tunnel established from router 2 to router 4. It has to go to router 1 and then come back on the router 4. So, but at the end, you have end-to-end reachability between all the hub and the spoke routers. Now, whenever we configure EIGRP, again, more similar to RIP as well, we need to keep in mind two things. We need to ensure that the multicast traffic must be enabled in order to establish the neighbor relationship. Now, either you can configure these commands at the time of the tunnel configuration, or you can do it later on. If you are making any changes later on, just if the neighborship is not coming, try to shut down the tunnel interfaces and make it back up. And the other thing, we need to ensure that we also disable the split horizon rule on the hub routers. Now these two things we need to add only on the hub router, that is on the router 1 and under the tunnel interface commands.